Today's lesson is 11-6b. We're again today going to simplify radical expressions with numbers and variables in the radicand. A review of yesterday, radical expressions is an expression that contains a radical sign. So here's our radical sign right here. We usually know that again as the square root. Again, the index right here is a number, and if there is no number there, it's automatically a 2, or it's understood to be a 2. And then there's numbers and or variables that are underneath the radical sign are called the radicand. Now yesterday we looked at, every time we looked at one of these, our index right here was a 2. Today we're going to look at it whenever our index is a 3 or a 4 or a 5. You don't have to write these examples. Again, review from yesterday, 16 is made up of 4 and 4, so you have 2 4s. So that's why the square root of 16 is 4, because you have a group or a pair of 4s, and we got used to circling those pairs of 2 or groups of 2 yesterday. Today we're going to look at things, like I said, our index here is going to be 3, and we want to look at the third root of 8. Well, when I birthday cake 8, I get 2 times 2 times 2. So since it has an index of 3, I'm looking for a group of 3 this time before I start circling. So instead of just looking for pairs or groups of 2, I'm going to look at my index. My index here is 3, so I'm looking for 3 of the same before I put that circle around it. So this is read as the cube root of 8 equals 2. So it says read as the cube root of 8. The index of 3 means that you must find the number when it is raised to the third power equals 8. So this would be 2 to the third, which the third root and the third power would cancel, and I would get 2. Again, a little bit of review from yesterday. It's in simplest form when the radicand has no perfect square factors other than 1. I'm not allowed to have a fraction underneath my radical symbol, and I'm not allowed to have a radical in the denominator of a fraction. Alright, I went ahead and wrote the prime numbers at the top of my paper, and I want you to do the same thing. Go ahead and write those prime numbers up there so that you know what you're allowed to divide by. And number 1, we have a 4th root. That's what that little 4 right there means. That's an index of 4. So a 4th root of 64 n to the 4th. So make sure you have number 1 written down. Alright, and just like yesterday, I need to break that 64 number down into its prime number. So I'm going to upside down birthday cake it. So I'm going to come over here, and I'm going to write down 64. And then I like to start dividing with the smallest prime that I can first. So I'm going to divide 64 by 2. So I'm going to say 64 divided by 2, and I'm going to get 32. Again, I can divide 32 by 2. And I get 16. And I can say 16 divided by 2, and I get 8. I can divide 8 by 2, and I get 4. I can divide 4 by 2 and get 2, and 2 by 2, and I get 1. That's a great old big upside down birthday cake. Alright, so then I'm going to rewrite this. Make sure you keep your little 4th root right there. That lets you know you have an index of 4. If not, it's a square root. So a square root, it's a 4th of a root. So instead of writing 64, I'm going to write 2 times 2 times 2 times 2 times 2 times 2. So I have 1, 2, 3, 4, 5, 6 2's. And I'm going to write out my 4 n's. And now I look at that index. It's a 4th root, so I need a group of 4. So I have to have 4 of the same number in order to circle. And here I have a group of 4 2's. 1, 2, 3, 4. So I'm going to put a circle around 4 of those 2's. And then I also have a group of 4 n's. So I'm going to put my circle around my group of 4 n's. So this is the same thing as 2 to the 4th. So the 4th root and the 4th power cancel, and I'm just left with 2. Then again, this is n to the 4th, and the 4th root cancels, so I'm just left with n. So I can take out a 2, and I can take out an n, because those are the things that I circled. Now I still have my 4th root, and I have 2 2's left, so instead of leaving it as 2 times 2, I'm going to multiply those back together, and 2 times 2 is 4. So my final answer here is 2n, 4th root of 4. Please make sure you have all of that work down before you move on. All right, number 2, I have the 3rd root of 24x to the 3rd. So this is telling me it's a 3rd root, or a cube root. I have a number inside the radical, so I know I need to come over here and upside down birthday cake that number. So again, the only numbers I'm allowed to divide by are these prime numbers up here. I can't divide by whatever I want to, like I can't divide by 6 here because 6 isn't prime. Only the prime one, so I'm going to divide by 2 first. 24 divided by 2 gives me 12, and then I can divide 12 by 2, and I get 6. 6 divided by 2, and I get 3. Now here I have to divide by 3, and I get 1. There's the 1 or the candle. Again, I know whenever I get that 1, I'm finished. So instead of 24, I'm going to say 2 times 2 times 2 times 3, because those are the primes that make up 24. And then I'm going to write my 6 x's, 1, 2, 3, 4, 5, 6. So once I've rewritten it, again, I'm going to look and say, okay, this is a 3rd root, so I need a group of 3 of the same in order to circle. And I have a group of 3 2's. And I have 2 groups of 3 x's. So that shows me what I can take out. Again, because this is the same thing as 2 to the 3rd, x to the 3rd, x to the 3rd, and these 3rd roots and 3rd powers cancel, and I'm just left with 2xx. So again, I can take out the 2, so I have a 2. I can take out 2 x's, so I can write that as x squared. And then I have to leave my 3rd root, and I have the 3rd root of 3. Because I have a 3 left that didn't get circled, so it has to stay. And again, please make sure that you remember to write your little 3rd root right here. A lot of times we forget to do that. That is your final answer. Please make sure you have all of that work down for number 2 before you move on. All right, number 3 says 7 5th root of 96y to the 6th. So I need to come over here and birthday cake 96. I'm not birthday caking 7 because it's on the outside of the radican, or the radical sign. So I'm going to start dividing. I'm going to say 96 divided by 2, and I get 48. 48 divided by 2, and I get 24. 24 divided by 2, and I get 12. 12 divided by 2, and I get 6. 6 divided by 2, and I get 3. 3 divided by 3, and I get 1. So again, instead of 96, it's made up of 2 times 2 times 2 times 2 times 2 times 3. So that's 1, 2, 3, 4, 5 2's and a 3. So I'm going to say 7 5th root, and I'm going to write out all my 2's and my 3. I've got 1, 2, 3, 4, 5 2's and a 3. And I have 6 y's. So 1, 2, 3, 4, 5, 6. So now, since this is a 5th root, I need 5 of the same in order to circle. So I have 5 2's, so I can circle these 2's right here because I've got 5 of them. And that's the same thing again as saying 2 to the 5th. So the 5th root and the 5th power cancel, and I'm left with 2. And then here we have 1, 2, 3, 6 y's, so I can circle the 5 of them. I can't circle that 6th one because I'm looking for groups of 5. So that's the same thing as y to the 5th. So again, 5th root, 5th power cancel, and I'm left with y. So let's look at this. I'm going to bring my 7 down. I'm going to bring out my 2 that I circled. I'm going to bring out my y that I circled. And I'm left with the 5th root. And I have a 3 and a y left that have not been circled. So the 5th root of 3y. So now I'm going to multiply the 7 times the 2 that I brought out, because whatever I bring out to the front, I multiply by whatever's already there. 7 times 2 is 14, so I have 14y, 5th root of 3y. That is my final answer. Please make sure you have all of that work down before you move on. All right, go ahead and write down number 4. You have 2 fourth root of f to the 4th, g to the 6th. Okay, now I don't have any numbers underneath my Radican, so I don't have to upside down birthday cake. I'm just going to write out my f's and my g's. I have 1, 2, 3, 4 f's and 1, 2, 3, 4, 5, 6 g's. And I need groups of 4 since this is a 4th root. So I have this group of 4, and then I have 1, 2, 3, 4. So I have a group of f's and a group of g's. So I'm going to bring those to the outside. So 2, F, G, and then I still have to keep my little 4th root. If there's nothing left in the radical, you don't need it anymore, but here I have something left that's not been circled. I have 2 G's, so I'm going to multiply those back together and say that it's G squared. That is my final answer. Please make sure that you have all of that work down before you move on. All right, here's number 5. We're getting back into our fractions just like we did yesterday, but I have a 3rd root of x to the 4th over 27. Again, the same way as yesterday, I'm going to look to see if I can reduce this, and I can't because there's no numbers to reduce and there's no x's in the numerator and denominator. So I'm going to do the same thing I did yesterday. I'm going to go ahead and split this up and say the 3rd root of x to the 4th and the 3rd root of 27. Now, I guess we could kind of tell, like, if it was a perfect square, then we knew that the radical sign was going to disappear for us in the denominator. I don't really know my perfect cubes as well as I know my perfect squares. So I'm going to go over here and upside down birthday cake 27. And 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So again, I went through and divided by my prime numbers until I hit 1. So I'm going to rewrite this, and on the top I'm going to write out my 4 x's, and on the bottom I have 3 3's. So this is actually going to work out nice for me since I'm looking for a 3rd root. There are 3 3's here, so I'm going to circle those. There's nothing left in the denominator that hasn't been circled, so my answer is just 3. Now I have a group of 3 x's on the top, so I can take out an x, but I still have to have the 3rd root of x because I still have this one x right here that's not been circled. So again, now I'm completely simplified. I took out my x to the 3rd right here. I got rid of my fraction that was in my radical sign, and I got rid of my radical that was in my denominator. So this is completely simplified. Make sure you have all of the work written for number 5 before you move on. Okay, go ahead and write down number 6. We have the 3rd root of 27a to the 7th over 9a to the 4th. Like I said, make sure that you can't reduce this first. So I'm going to use the alpha y equals of my calculator. I'm going to put in 27 over 9, and I get 3. So I can reduce this to 1 and 3. Also, instead of a to the 7th, I can write out my 7 a's. 1, 2, 3, 4, 5, 6, 7. And instead of a to the 4th, I can write out my 4 a's. 1, 2, 3, 4. That way I can look and cancel. These 2 can cancel, these 2 can cancel, these 2 can cancel, these 2 can cancel. So 1, 2, 3, 4 on the bottom cancels with 1, 2, 3, 4 on the top. So now I'm going to clean this up and see what I've got left. I have the 3rd root. I have a 3 and 3 a's. Left on the top. I don't have anything but a 1 left on the bottom. So since I don't have anything but the 1 left, I can just change this to the 3rd root of 3a to the 3rd. I don't need that 1. So my denominator went ahead and canceled itself here because it was just 1. Now I need to see if I can reduce this. I can't reduce 3 because it's a prime, and then I have 3 A's. So I have a group of A's, so I can take an A out. So I have A third root of 3. The 3 has to stay because it's not being circled. Please make sure you have all of that written down for number 6 before you move on. Okay, go ahead and write down number 7. We have the 4th root of 6n to the 5th over 32. Now again, I'm going to look to see if I can simplify this down. So when I put that into alpha y equals in my calculator, I end up with 3 over 16. Now I can't do anything with the n's because there's none on the bottom, so I'm going to say 4th root of 3n to the 5th over 16. Now since I can't reduce anymore, I'm going to go ahead and split this up and say the 4th root of 3n to the 5th over the 4th root of 16. Now I don't know if 16 is a perfect 4th root, so I'm going to go over here and birthday cake it. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So I do actually have 4 2's. So I'm going to come down here and say the 4th root of 3. Now 3 is prime, so I don't have to birthday cake that. But I do need to write out my 5 m's over the 4th root of, and I end up with 4 2's. Okay. So again, this one's going to work out nicely. I needed a group of 4, and I have a group of 4. I also have a group of 4 n's on the top. So on the top I can take out an n, and I'm left with the 4th root of 3n, because I have a 3 and an n left that have not been circled. On the bottom, everything's been circled, so it's just 2. So I'm good with simplifying. I pulled out the n. I don't have a fraction underneath this radical sign, and I don't have a radical in the denominator of this fraction. So that is my final answer. Make sure you have all of that written before you move on. All right, go ahead and write down number 8. We have the square root of 3d over 5. Now this time I don't have an index here, so I automatically know it's a 2, so I can write in a 2. So anytime you don't see an index, you can write in a 2. Now I can't reduce 3 and 5, so I'm going to go ahead and split it up and say the square root of 3d over the square root of 5. So here I have a 5 and it's prime, so I'm not going to be able to upside down birthday cake it. It's not going to turn out pretty, so I have to find another way to get that radical out of the denominator. I have 1 5. I need a pair or a group of 2 in order to circle. So if I have 1, I need 1 more so that I'll have my group of 2. Now I can do that as long as I also multiply the top by that. So now I'm going to go through and say the square root of 3 times 5 times d on the top over the square root of 5 times 5 on the bottom. Here I now have my group of 2 5's that I needed. So it's just 5. On the top, 3 and 5 can't be birthday cake because they're both prime, so I'm just going to multiply those back together and I get 15d. We looked at some of these yesterday that look just like this. So we have the square root of 15d over 5. Again, don't think that you can reduce the 15 over 5 because that's not 15, it's the square root of 15. Please make sure you have all of that work down before you move on. Alright, so with number 9, we have the third root of 3b over 4. Now this time we have a third root. I can't reduce 3 over 4. However, 4 is a perfect square, but it's not a perfect cube. So I'm going to go over here and birthday cake 4 and just see what I get. I get 2 times 2, and I upside down birthday cake it. So I'm going to go ahead and rewrite this as the cube root of 3b over the cube root of 2 times 2. Now here, this isn't going to go away because I need a group of 3 in order to circle, and I only have 2. So I need 1 more to make my group of 3 so that I can circle and no longer have a radical in the denominator. So I can put that 1 more third root of 2 in the denominator as long as I also multiply it by the numerator. So I can do that. Now we're going to rewrite the top of it and put everything underneath one radical. We're going to say 3 times 2 times b over the denominator. Now I have 1, 2, 3 2's in the denominator. So I have my group of 3. So that turns out to just be 2. So I got rid of the radical sign in my denominator. The numerator, 3 and 2, are both prime, so I'm just going to multiply those back together and get 6b. The big thing here again is not to reduce the 6 over 2 because it's not 6, it's the square root of 6, and also to make sure you still keep your third root in your answer and make sure you don't accidentally leave it off. So that is your final answer. Please make sure you have all of that written before you move on. All right, your homework will be a worksheet tomorrow, so this is the end of your video. Thank you for watching.